Okay, students, I'm going to review all 4 ways that we have learned to solve systems of equations all in this video. So you can watch this video and go back and do any of the assignments you haven't done. Make sure you've done the problems right, etc. If you want more practice problems, let me know. Put some more up there. If you need a particular one on one of your assignments, make sure you email me Wednesday morning, and I'll make a video for it and have it out by Wednesday afternoon at some point. Okay, so elimination method. Remember, elimination methods, we want to eliminate either the x's or the y's. First off, if I'm going to use elimination method, the equations are going to be in standard form. That's the smartest way as far as using elimination method. We want to make sure both equations are in standard form, which they are. If they weren't, I would need to put them in standard form, ax plus by equals c. But we don't care if a is positive or not. It just has to be ax plus by, and it doesn't have to be plus, it can be plus or minus. And then the constant over here. Okay. So we're going to do number one by elimination method, and then number 3 over here we're going to do it by matrices. Put it in a graphing calculator, straight up as it is. Okay, so here we go. So what I want to ask myself is, do I have to multiply both lines? So I ask myself, what's the common denominator between 2 and -4? It's -4. Well, the -4 is already there, so I don't have to multiply the top row by 2 to get a +4. So I add 4 and -4, it gives me 0, and then eliminate the x's. So I don't have to multiply one line, one equation in this case. But what if I want to eliminate the y's? What's the common denominator between 2 and 3? It's 6. So I'd have to multiply both rows here to get up to 6. This by, say, -3 to get -6, and this by +2 to make it +6. And then 6 plus -6 is 0. Or I could have made this one negative and that one positive, doesn't matter. But I have to multiply both rows to get up to a common denominator of 6, whereas here I don't have to multiply one row to get a common denominator of 4. So we're going to go ahead and do that. And so since the bottom row for eliminating the x's is -4, we want this to be +4x. So 4x plus -4x equals 0, because we're going to add straight down afterwards. So what do I have to multiply this top row by to get +4? A 2. Okay, so 2 is out front here. All right, so that means I have to distribute this 2 through everything in here. Can't forget, a common error is that people forget to do it by the constant over here. It's got to be by all 3. Don't forget that. You could rewrite it up here, or you could keep track in your head. 2 times 2 is 4x plus -4x, 0, gone. And just do one of these at a time. 2 times +3 is +6, plus +2y is 8y. This is all I do right here. If you want to rewrite this whole thing, distributing 2 through there and put it underneath here instead, and then add down that way, that's what some like to do as well. I just like to write less. And then 2 times 14 is 28, plus 20 is 48. And last step, divide by 8, and you get y equals 6. Remember, when I'm solving a system of equations, I'm finding the point of intersection, also called the solution. Those are your 2 vocab words for it. So that's x comma y. So I've only got a y right now, so I need to take this y, plug it back into either one of these equations, and solve for the x. Okay, that's what I'm just going to have you do. You could use elimination method again and eliminate the y's this time and solve for x. But like I said, we have to multiply both rows to get a +6 and -6. Most teachers will just tell you to substitute the y back in there. Now, if you're quick with math, doing the elimination method again, eliminating the y's this time, I sometimes do that one. Okay, especially if this counts to be a fraction. Being that this is an integer, it's easy to plug it back in. But if this counts to be a fraction, I don't want to plug fractions into here. So I just do the elimination method again, eliminating the other one the next time, and then I get the answer. All right, so we'll just plug it into the top one. So I get top equation, 2x plus 3, whenever we substitute in for parentheses equals 14. Okay, so I have 2x equals Now, remember that's plus 18, so I subtract 18 across. 14 minus 18 is negative 4. I'm just saving some time for video length here. And negative 4 divided by 2 is negative 2. Okay, so I write my point of intersection as a point. Negative 2, comma 6. Okay, there's my answer. That's where these two lines intersect, negative 2, comma 6. Now, I could go ahead and put this in a graphing calculator. I'll go ahead and quickly do that. It's not bad. Show you the matrix form right now with this one. Maybe I'll just do this one problem. I'll leave the other problem for you to do. So I'll do both of these. I just did it with elimination, and now I'm going to do it with matrices, and then I'll let you do that one with practice. Okay, for a practice one. Okay, this one has to be really easy because you add straight down, eliminates the y's right away. Okay, so that's a very simple one. This one was much harder than this one. Okay, so now I'm going to go ahead and do the same problem by matrices. So I'm not having to do any of this work. If I use matrices, the calculator will do it all for me. So this is a way for you to check on your calculator. Remember, this is a calculator-driven class, so you want to get your calculator mastered and how to plug in your calculator. So what we do, first off, we need to identify, write it in our matrix form here, okay? So this first one is called the coefficient matrix. And the second matrix we're going to be doing is called the constant matrix. Hopefully you're thinking about why that's the case right now. The first matrix we call A. The second matrix we call B. Okay. The coefficient matrix, because all four of these numbers here are coefficients. Remember, coefficient, you've already got tests on in the first test of the year, are numbers in front of variables. So we have 2, 3, negative 4, and 2. There's our coefficient matrix. We're going to call that one A. Our constant matrix, remember, constant is a number by itself. 14 and 20. And I call that one matrix B. So that's called the coefficient matrix. You got to get these vocab words memorized. Who knows if I just test you on the vocab for what these are called? Constant matrix. It should be easy because we've already had the words coefficient and constant at the beginning of the year here. We've talked about it all throughout. Okay, so now we're going to see how you plug in a calculator again. We've already done a video on this, but here it is again. Okay, so I go to second. Oh, before that, we want to identify the dimensions. Remember, when we identify the dimensions, it goes rows first for our dimensions, and columns second. So how many rows did we have? I just put down there on the left there. Okay, so you need to know these are columns. Over here, these are rows. So how many rows do we have here? 2. By how many columns do we have up here? 2. So it's a 2 by 2 matrix. How many rows do we have here? 2. How many columns do we have? 1. Okay. And so we need to know that because it's going to ask us what are our dimensions. So it's a 2 by 2 for matrix A and a 2 by 1 for matrix B. Then we come back to the home screen after plugging into the calculator. Go to home screen and type A inverse B. Enter. These are your X and Y coordinates. So the calculator do it all for you. So now you're going to watch me plug in A and B. Show you. You'll see how to do this again. Then we'll go back to the home screen and type in A inverse B, and it'll kick out our answers right there, and we're going to get this exact same answer over here of negative 2, 6. if we plug it in right and type A inverse B correctly on the screen. Okay, so how do we plug in a calculator again? Second, down here, x to the negative 1 is matrix. Oh, the second didn't stay. Second, inverse, there we go. Now, when you're inputting in the matrices themselves, that's under edit. Okay, so the first one, it's already under the first one, it's going to be matrix A. Notice it's already got a 2 by 2 matrix in there, but if we had a different, and that's what we're looking for. Our B, we want to be 2 by 1, so we're going to change those dimensions. It's already got a 2 by 2 in there now, but we'll change those. These already have the correct dimensions, but if they didn't, we would need to change that. So enter, notice it has them correct, so we can just hit enter again. Enter, enter, now we just input those. So going back to the screen, what were our numbers? 2, 3, negative 4, 2. It goes across, 2, 3, negative 4, 2. So 2, 3, enter, negative 4, 2. Okay, so we got it in there. You go, check it, make sure you plug in right. Now do second matrix again. Add it again because we're inputting a new matrix. This time we're going down to B though. We don't want A again. We just did A. We're going to do a new name, B. Right now that's got a 2 by 2. Remember, we want it to be a 2 by 1. So when we get over here, we're going to change it to a 1. Hit enter. And we go back and look what its matrix was, 14, 20. Okay, so we type in 14, enter, 20, enter. Okay, and remember what it said to do after that? Go back to the home screen, second quit. And on the home screen, remember what it said to type? See if you can tell me right now before I bring it up. A inverse B. We're going to type that on the screen. It's going to kick out these two answers right there. So, second matrix again. This time, we're not going to use edit because that's for inputting information. We've already input our information, so now we want the names of them on the home screen. When you're going to plug it on the home screen, you only go under names. You don't use edit on the home screen. Edit's to input the matrices themselves. Once we have them in to put stuff on the home screen, we use the names only. So A, remember we're doing A, inverse is the same one as that matrix key. Okay, inverse, and then do second matrix again, and go down to B. Remember, we're using the names because we're putting it on the home screen, not the edit one. There's A inverse B. What's the answer going to be? Who knows? Oh, look it. We must have done it right. Negative 2, 6. The exact same answer that we have here, negative 2, 6. All right, so we just did two methods. Elimination method by hand right here, and matrices, solving systems by matrices on the calculator. Now let's go ahead and do it by graphing. You're going to go graphing by hand and graphing by calculator. Both. By graphing by hand and calculator. Okay, we know this is what form? Slope-intercept form. You should already be able to tell me that. Y equals mx plus b. M equals slope written as a fraction. B equals y-intercept written 2t 3 I put 3 written 0 comma b, whatever the b is. Okay, so for equation 1, our m equals 4 over 1. Okay, and b equals 0 comma 3. Equation 2, we have m equals negative 1 over 1. Right, and as a fraction, if these are integers, we always put them over 1. If they're always a fraction, we just leave it as the fraction itself. But these are not fractions, these are integers, so we put it over 1. Okay, and our b here is 0 comma negative 2. Oops, negative 2. Okay, so which one of these is a point? Is slope a point? Okay, we want to put our arrows. Remember, changing y, so positive y is up. Positive x is to the right. These are directions to other points. Negative y is down. Remember, slope is changing y, we're changing x. Dang it. And positive x is to the right. So put your arrows there. Okay. You don't try doing this in your head, Caden. You write it down on paper and you follow the directions. So again, these are points. These are directions to get to other points. I want two at this point plus two others. So 0, 3. 0, 3. Right there. Now, notice it says go up 4, right 1. Well, that would take me off the screen. So don't forget, negative 4 over negative 1 also equals positive 4, doesn't it? You better say yes. So I can go ahead and go down 4 and left 1. And notice that will take me on the screen. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. Okay, so there's that line. So go ahead and draw a line through those. Okay, obviously I have to adjust it here slightly and slightly. Okay, that's pretty close right there. You have a ruler, you can do it. And then for the second one, I start at 0, negative 2. You got to know how to plot 0, negative 2. If you can't plot that, you can't do these problems. By hand, that is. Obviously, we're going to show you how to do it in a calculator. But this you've been doing since 7th grade. You've done this in 7th grade, 8th grade, now you're in 9th grade, 3 years in a row. You better be able to graph lines. All right, and it says go down 1, right 1. There's point 2. Go down 1, right 1 again. There's point 3. Okay, now go ahead and do your line. So I put it right on through there. Right there. Okay, and notice we can see our point of intersection right here. Right here is our point of intersection. What is that point? That point is, better say it already, -1, -1. Okay, that means, and just so you know, even on the test, I'm going to have it count to be integer answers like this. No fractions. If you're not getting fractions, they're going to always intersect right at nice corners, even on the test. Okay, so now we're going to play in the graphing calculator. Notice it's already in slope-intercept form. So the graphing calculator, we already have that nice feature of y equals. See, in the past, nobody's taught our Algebra 1 kids or even Algebra 2 any longer recently how to put in the standard form in the calculator like we did in problem 1. So they all had to solve for y in order to plug it in here to test. Okay, so plug it in. Oops, let me make this a little smaller so we can have both up there. Okay, there we go. Y equals 4x plus 3. And y equals negative. You got to use the negative sign, not the minus sign. Now you use the minus sign. Okay, and from our video that I've done before, remember, we do second calc, which is the trace button. Number 5, intersect. And there's the two lines. So you can see the two lines right there, exactly what we have right here. And then we just hit enter, enter, enter. And there's our answer, -1, -1. Exactly what we have right there. So now there's no excuse. You're seeing it again. I'm putting all these together. Okay, on one video. Instead of 3 separate ones. Now you get them all together. So you can watch them. If you have to write down each step. Remember, you're going to use open notes on the tests. So if you don't have it memorized, the exact buttons what to press, then you need to rewind the video and watch me as I go through it and write down on your own paper for notes the steps that you type in a calculator. There's no excuse for everybody not getting these right because I've shown you step by step, plugged it in the calculator right for you to watch. If you're too lazy to write it down, then you don't want to go ahead and get the right answers and get a good score on the test. That's laziness. Write down your steps. You don't have to have them memorized. Like if we were in person in school, you'd have to have these memorized. I'm not letting you use the notes on it. You get to now you're at home, you can look at, you're getting an easy break now. You got to have the steps written down and just copy right down and follow your own steps. If you're too lazy to write down the steps, and you're too lazy to get a good grade. Okay. Last one, substitution method. The reason we would use substitution method is because one of the equations is solved for the variable. In this case, you see the second equation is solved for y. So that means I can, anytime I see y, I can go ahead and substitute in negative 5x minus 17. Okay, that can go right into this whole thing, goes right into there. So that's what we're going to do. And remember, whenever you substitute, you put parentheses around it. So I got negative 3x minus 3 times parentheses negative 5x minus 17 equals 3. What are we going to do next? Everybody should have said distributive property. Negative 3x plus 15x x plus 3 times 17 is 51 equals 3. Okay. All right. Now what's our next step? Everybody should have said combine like terms or add like terms, whatever you prefer. 15x minus 3x, 12x plus 51. Oops, backwards here. Equals 3. What is our next step? First off, how do we solve all equations? Reverse PEMDAS. Should already have that down. P, E, M, D with, oops, arrow going that direction for left to right, whichever comes first, and AS. And remember, we're doing reverse for solving equations. So we're going up. Order of operations. If we just had all the numbers, or combining them, make them simplified to one number, we would be going down. Whenever you solve equations, you go up, reverse order of operations, or reverse PEMDAS, same thing. Okay, so what's my next one? So we don't start applying this until we deal with distributive property and combining like terms first, and now we're doing reverse PEMDAS. So now we've combined like terms, we're to here, so now we're doing reverse PEMDAS. Add, subtract across first. Yes, we want to, since this coefficient on the x, which we're trying to solve for 1x, so we get rid of the 12 and the 51 to the other side. Since the 12 is positive, we're going to go ahead and leave the x on this side. If this was negative, I would have told you to move it to the other side and bring the constant across. So we always divide by negative. It is positive, so we're leaving it there. All right, so next, subtract. Remember, add or subtract. How do you move anything across the equal sign? The opposite operation has never changed in all of math history. Memorize all this stuff. You got to teach your kids. You're responsible for making sure your kids know this when they're in middle school or earlier if you want them to be smart, real smart. 12x equals, what's 3 minus 51? Negative 48. What's the last step? How do we get rid of the 12? Remember, we're solving for x. How do we get rid of the 12? What does 12x mean? 12 times x. How do we move anything across the equal sign? Do the opposite operation. So what's the opposite of multiplication? Division. So we are dividing by 12 on both sides. Oops, get rid of that underline here. I didn't think I was going to do that yet. Oops, what happened to my negative 48 here? Okay, let's see if I can go backwards here. Did it just wipe out the neg? Oh, there we go. Okay. Okay, underline. 12 on both sides. And therefore, my last step is x equals -4. Now, don't forget, that's the only last step of getting x. So you see how much more work substitution is. Substitution is the one that students make the most errors on because there's so much work. You can see all the possible errors along the way. And we've only got x. Now we got to plug this x back into the x right here. And then we can solve for y. So we have y equals -5. What do we do when we substitute back in? Put parentheses around it. -17 equals. What's negative times negative? Positive 20 minus 17 equals 3. And there's my answer. Y equals 3. So remember, I write it down as a point. -4, 3. Now, if I want to guarantee I'm right, remember, we just had to fit in this equation. If it fits for this equation, so that means it fits for both. Now, if it's going to check it, if it fits for this one, if it's true for this one, and we already know it's true for this one, if it's true for this one, you know you got the right answer, guaranteed. So let's plug it in there. We're just going to do it in our head, mental math, because this is basic math, middle school math. -3 times -4 is 12. -3 times +3 is -9. 12 minus 9 is 3. Yes, that's true. Check. Where do you check there? If you want to check it again, 20 minus 17 is 3. Check. Therefore, you're guaranteed to have it right. There is no excuse for missing this on the test. If you don't get to work out, you made an error, basic math error here. Use your calculator. If you can't do it, if you're not really good with integers, then you better be putting all this in your calculator. It's going to take you longer because you haven't chosen to memorize your integers well since middle school. But more important is you get the right answer. Okay. If you also want to check it another way, I could have solved this. So this is already solved for y, and then we can put it in the calculator. I would have to solve this one for y. I could solve for that one for y. I'll go ahead and do that. If you want to really check it, you weren't confident in your ability to plug stuff in and all that, I could solve this equation for y and then plug both of them in the calculator like we did on the graphing one, last one. So if I was to do that, I'm going to make it short. I'm moving the -3y across. I get +3y, subtract that across, and I get 3y equals -3x minus 3. Last step, I'm dividing by 3 on every term, and I get y equals -1x minus 1. Okay, so I have that equation and that equation. I can put that in the graphing calculator now. Let's plug them in. -x minus 1, enter. And what was the other one here? -5x minus 17. And who can tell me the steps? Say them out loud, how I get the intersection point, also called the solution. Second trace or second calc, number 5. And hit enter 3 times. 1, 2, 3. And look at my answer, -4, 3. Isn't that exactly what we had? Right there, -4, 3. Guaranteed it's right. Okay. Now, of course, that means you have to be able to solve for y correctly. A lot of Algebra 1 problems because students still can't solve for a variable in an equation from middle school. You've been doing this since middle school because, again, you don't know your integers, you don't know reverse PEMDAS, etc. But if you know your basic middle school math, you could easily solve it for y, plug both of them in the calculators we just did there, and check your answer. All right, that's it. Know this stuff for your test and your assignments.